Hello, everyone. My name is Kevin McCabe with the National Renewable Energy Laboratory. Welcome to today's webinar, hosted by the Carbon Capture, Utilization, and Storage, or CCUS initiative, an initiative of the Clean Energy Ministerial. Today's event is brought to you by representatives from the Netherlands, including entities from both the governmental and private sectors. Before we begin, I'll quickly go over some of the webinar features. For audio, you have two options. You may either listen through your computer or over your telephone. If you choose to listen through your computer, please select the mic and speakers option in the audio pane. This option is preferred as it will eliminate the possibility of feedback and echo. If you choose to dial in by phone, please select the telephone option, and a box on the right side will display the telephone number and audio pin you should use to dial in. If you encounter technical difficulties with the webinar, you may contact the GoToWebinar's help desk at the number shown on the screen. If you would like to ask a question, we ask that you use the questions pane where you may type it in at any time during the webinar. Shortly following the conclusion of the event, the recording will be added to YouTube and the presentation slides will be uploaded to the Clean Energy Solutions Center site, links for which can be found on this slide. The recordings from previous webinars held by the CCUS initiative are hosted in a dedicated YouTube playlist. Follow the link on this slide. As another reminder, slides will be posted following the conclusion of the event, or simply search for Clean Energy Solutions Center on YouTube and click on the Playlist tab. The SEM CCUS video playlist can be found there. Before we begin the presentations, I'll provide a quick introduction of today's panelists, followed by a brief welcome from Jared Daniels of the SEM CCUS initiative and the United States Department of Energy, who will provide context for today's webinar. Then, following the panelists' presentations, Jared will moderate the Q&A session, where the panelists will address questions submitted by the audience and engage in a broader discussion of the topics at hand. Our first speaker today will be Jared Daniels, who leads the Office of Strategic Planning, Analysis, and Engagement within the United States Department of Energy, Office of Fossil Energy. Following Jared will be Tom Mukunda, Senior Policy Advisor for the Netherlands Ministry of Economic Affairs and Climate Policy. Unfortunately, our originally planned speaker, Mark Drysdale, encountered a sudden personal matter and is unable to present today. We wish Mark the best and note that in his stead will be Bram Sommer, Advisor of Public and Regulatory Affairs with the Rotterdam CCUS project Porthos. Finally, we will hear from Ludo van Geiste, Managing Director of Carbon Collectors BV, based in Groningen. And with those brief introductions, I would now like to welcome Jared to the webinar. Jared.
Great. Well, thank you very much, Kevin. Give a brief overview here of our carbon capture, utilization, and storage initiative under the Clean Energy Ministerial. If we can have the next slide, just to highlight the Clean Energy Ministerial itself. The Clean Energy Ministerial was founded in 2009 as a high-level global forum to promote policies and programs that advance clean energy technologies broadly, to share best practices and lessons learned, and to encourage a transition to a global clean economy. The SEM currently represents 27 members, representing over 90% of clean energy investments and about 75% of global CO2 emissions. Several years ago, and under that broad Clean Energy Ministerial, we stood up the CCUS initiative as a focused effort to ensure that CCUS was part of that broader low carbon energy conversation. The lead countries for our CCUS initiative are Norway, Saudi Arabia, the United States, and the United Kingdom. We currently have on the order of a dozen countries as part of the initiative, and again, all underneath the broader Clean Energy Ministerial. This initiative's work is done under the SEM, but it does dovetail nicely and work iteratively with other organizations who are active in the CCUS space, including the Carbon Sequestration Leadership Forum, various auspices under the IEA, Mission Innovation, the Global CCS Institute, and some of our partners on the industrial side, the Oil and Gas Climate Initiative, and some of their work. So on the next slide, the SEM CCUS initiative really focuses on just several key things: to actively include CCUS as part of the broader clean energy conversation. If all the math and all the analysis state that CCUS needs to be part of our decarbonization paths moving forward to meet our mid-century climate targets, we want to make sure it's in that broad, all of the above conversation. We also look to facilitate bringing together governments and the private sector and the investment community to all talk about CCUS, how it needs to be an integral part of that overall broader portfolio of efforts, and to find ways to work together to do so. Specifically, we look to facilitate identifying both near-term and longer-term investment opportunities to advance CCUS deployments globally, and also we look to share best practices in CCUS policy and regulation and investment. So with that as a brief overview and introduction, hopefully you now know where this initiative sits and where our conversation today will take place. With that as a quick entry point, I'm happy to move on to the main part of our webinar today, presentations from our three panelists that were already introduced. First, we will hear from Tom from the Ministry of Economy Affairs and Climate Policy. Bram will then follow Tom with some perspective from the Port of Rotterdam. Ludo will then give his perspective from carbon collectors that he and his colleagues are working to progress CCUS. And then we will have a hopefully robust and healthy Q&A session at the end. So again, I invite you to enter your questions into the chat. We'll take note of those as we go. And that is the plan for the remainder of the hour. So with that as an introduction, Tom, the floor and our attention are yours.
Hi, Tom, we're having a little trouble hearing you. Very slightly.
Is this any better?
That is better.
Okay, then I'll leave my camera off for now. Thanks.
Okay.
Okay. So next slide, please. Okay, thanks. So today I'm just going to briefly go through the current status of developments of CCS in the Netherlands, how it falls into place with the National Climate Agreement, why CCS is an important technology for the climate targets of the Netherlands, briefly introduce some of the main aspects of how CCS policy is being implemented in the Netherlands, and particularly through the SDE++ tender mechanism, a dedicated policy support system for low carbon technologies, including CCS, and then outline a couple of future policy challenges that we see ahead of us that are going to be important in the coming years. Next slide, please. So this is an overview of the Dutch Climate Agreement, and it's unfortunately not translated into English yet. But just to give you an overview of the main targets of the Climate Accord, basically it was an agreement in 2019 to reduce the CO2 emissions by 49% compared to 1990 levels by 2030. To put that into perspective, hopefully at the end of this year we'll be around the 25% reduction mark. So that underlines the significant step change that we need to reduce emissions over the next 10 years. So quite considerable. So roughly speaking, that boils down to a reduction of close to 50 megatons of CO2 per year, of which this target has been spread over a number of sectors in the Netherlands. Particularly relevant for CCS is the industry sector, where the target is 14.3 megatons CO2 reduction per year by 2030. So in order to achieve this, there's a number of policy mechanisms, a policy being put into place, namely a carbon levy or a carbon tax on CO2 emitted, which aims to increase the impact of the ETS. So this is on top of the current ETS price. Secondly, in order to enable companies to make the necessary investment in decarbonization technologies, The existing subsidy scheme called the SDE++ is being expanded also to include CCS. We also have a public-private innovation program for reducing the costs of technology and low carbon technologies in the long run, and are facilitating industrial clusters to help reduce costs and reduce risks of implementing CCS. Next slide, please. So this gives you an overview. It's a marginal abatement cost curve of Dutch industry, and you can what you can see is the different types underneath, the different possibilities for reducing emissions in industry, namely CCS, electrification, process efficiency, hydrogen, and other measures. And what's an important message to take away from this picture is you see the CCS being the green bars, and you can see quite largely the large technical potential for CCS across industry. On the x-axis, you can see the megatons, the approximate amount of CO2 in megaton CO2, and what you can see is that large chunks of CO2 emissions can be reduced through CCS, and actually quite an awful lot can be reduced for less than 100 euros per ton of CO2, which is quite cost efficient. So this has been sort of the reason why, and this is from the Netherlands, the Dutch Environment Agency, and they have, and this is the analysis they did to have a look at where emissions can be reduced from industry. Next slide, please. So on top of the considerable techno-economic potential for CCS in the Netherlands, we also have considerable. Most of the emissions of the country are clustered into sort of industrial clusters. So here you can see the largest emissions from the Port of Rotterdam region, with quite considerable petrochemical industry and necessary utilities, and waste incineration, waste to energy plants. You'll hear a bit more about the Porthos project from Bram in a few moments' time. Also, of course, very important for CCS is the availability of offshore storage. And there, on the right-hand side, you can see an overview of the main large gas fields on the Dutch continental shelf, many of which are coming to the end of their exploitation phase and can therefore potentially be used for CO2 storage. And of course, that goes in line with that is the existing oil and gas assets, and also platforms and potentially pipelines that can be reused or play a function in the future development of the CO2 transport and storage network. As I said, CCS has had a lot of attention from the research and innovation sector, and that's really bearing its fruits now as we move into implementation phase. Okay, next slide, please. Okay, just briefly, so some of the key aspects of the CCS policy. So indeed, CCS does remain a controversial topic, and it was a very controversial topic during the negotiations of the 2019 climate agreement in the Netherlands. So in order to ensure that CCS doesn't enable the fossil fuel industry to become locked in for future years, there have been a number of measures taken in place to limit the role CCS can play as a transition technology. And that is done in three ways. First of all, a cap on the amount of subsidy that can be made available for CCS. So that's 7.2 megatons in total. So that's approximately half of the target, if you can remember, from the 14.3 megatons expected to be reduced from industry. So there you can see CCS is playing a very considerable but controlled role in CO2 reductions from industry. Secondly, every year we undertake a study to explore different alternatives for CCS. Specifically for different industries, to ensure that CCS is only subsidized if there are no cost-effective alternatives. And there also is the horizon, which we call, which is so that means that after 2035 there'll be no further subsidies granted to fossil CCS projects. So CCS is initially for industry sectors where no cost-effective alternatives exist. In order to achieve this, we're making a CapEx and OpEx subsidy available, which I'll talk about in a few moments. And we also see a role for negative emissions, particularly after 2030, once the right regulatory framework gets put into place. Next slide, please. So the SDE policy mechanism, a bit of information here. I will try and go through it as quick as possible. So it's an existing policy mechanism that was actually initially implemented to stimulate sustainable, the generation of sustainable power. And for 2020, it's been adjusted to be based on a ranking on, it used to be on euros per kilowatt hour, and now it's been adjusted to be euros per ton of CO2 reduction. So the subsidy is based on the is a CO2 reduction premium based on the cost price, and it also takes into account revenues, in this case being the existing incentive to reduce emissions provided by the European Union Emission Trading Scheme. It covers CapEx and OpEx of a project over a 15-year lifetime, and it also includes transport and storage. Something that's specific to CCS is because CCS is a relatively new and complex technology. This existing subsidy round will be done on an open book basis, which means that once the costs have been made by the project has to the project implementers have to show us the costs made. So there may be possible corrections to avoid over subsidy in this initial round. There are a few other requirements that CCS projects have to have in place. They have to complete feasibility studies, have agreements in place for CO2 storage, and they need to be realized within 5 years of the subsidy approval. And next slide, please. So this just gives you an idea of how the SCE encourages the most competitive technologies to come forward on a tender basis. So basically, each year the estimated costs of the different technologies are calculated by the Netherlands Environment Agency, and they provide a maximum subsidy intensity for which CCS projects can apply for. In this initial round, the lowest subsidy intensity for CCS, the minimum is 63 euros per ton of CO2, but it does increase to approximately over 100 euros for more it's between 60 and 100 euros depending on the type of project, whether it has existing capture facilities in the case of steam methane reforming with hydrogen for hydrogen production, for example. So what you can see is that the earlier you apply for the subsidy, so for example in the bottom table, phase 1, so if you apply for your project in this initial phase, you have the greatest chance of becoming successful with your application, because the budget is limited around. So for 2020, the budget for all projects of the SDA is limited to a total of 5 billion euros. Next slide, please. This is just to give you an overview of the how the SDE mechanism only provides subsidy for the unprofitable parts of the project. So you can see the purple bars indicate the subsidy, and the green bars indicate the market remuneration. In the case of CCS, this would be the ETS price, or the emissions trading price, and that is adjusted on a yearly basis. So the subsidy is then is adjusted on a yearly basis based on the ETS price. Yep. So next slide, please. Just to touch on a few future policy challenges, I think into my last minute now. So maintaining political and public support for CCS is very important, and that's why it's very important that we continue to review the alternatives for CCS, and have very transparent communication about the role that CCS is going to play in reducing CO2 emissions in the Netherlands. In future rounds of the SDE Plus, we may need to include more complex CO2 capture and transport systems. Currently, the amounts potentially only focus really on low cost CO2 reduction, for example, for industry processes such as hydrogen. But in the future, potentially the SDE will be expanded to include post-combustion capture systems, and that would allow a greater number of industrial point sources to be addressed. The long-term liabilities for CO2 storage is a regulatory issue that we are trying to find a way to become more efficient, because there has to be a considerable amount of financial security provided for these long-term liabilities, and in the end, with the high targets for CO2 storage, these financial security amounts can really be an issue for the technology moving forward. We also have to ensure that the sufficient CO2 storage capacity is prepared. This is your typical chicken and egg scenario. It costs a lot of money to get CO2 storage sites ready, getting the permit processes up to speed, having the site properly site characterized, taking potentially doing exploratory drilling to understand these storage sites. This costs a lot of money. But at the same time, it may be that for example, a storage provider doesn't have a contract in place with a CO2 emitter, and in which case they would be reluctant to make these investments. On the other side, a CO2 capture, a potential capture project may be hesitant to make the investment because they don't know where to send their CO2. So I think we really need to have some form of intervention there from the government to ensure that the CO2 storage capacity is prepared on time to allow the CO2 capture projects to take place. And finally, we need to prepare for international CO2 transport in terms of getting bilateral agreements in place, and also providing regulatory clarity around the use of shipping, both inland and maritime shipping, for the transport of CO2, and ensure that the CO2 can be transported in line with the existing emission trading scheme. And I think that's it. So if you didn't hear me at the start, I'd like to thank the SEM for inviting and organizing us, and also for the presenters who we will hear from in a moment's time. So thank you.
Well, thank you, Tom. I just also want to thank the organization for the opportunity to present the Porthos project here. And well, I'll act as a stand-in for my colleague, Mark Drysdale, who unfortunately, due to private circumstances, can't attend. I'll give you a short overview of the project and of the situation in the Netherlands and the Port of Rotterdam. So next slide, please. Well, most of this Tommy Koende already told you. I just want to highlight again the 7.2 megaton CCS that well will need to be realized by the industry to reach all the targets for the climate goals in 2030. And well, the importance in the Netherlands to achieve a CCS infrastructure. Next slide, please. And to reach this infrastructure, Rotterdam is the ideal location. We tend to joke that if we as Porthos don't succeed in the realization of the CCS infrastructure, well, probably nowhere else it would be possible. Naturally, Norway already shown us the way that elsewhere it is possible. So now we need to achieve this as well. Why is Rotterdam ideal for CCS? Well, it's a large industrial cluster in relatively small area with the storage locations just, well, around approximately 20 kilometers offshore. And with a large industrial cluster, as mentioned, with 60% of the national CO2 emissions, that amounts to approximately 30 megatons just from this area. So all this makes it a very cost-effective area to utilize CCS to achieve the climate targets. And sorry, oh, and CCS doesn't stand on itself in the Port of Rotterdam. It's part of the harbor of the future, as it's called. So the CCS infrastructure will be built together with hydrogen infrastructure, and in the future, CO2 will also be seen as a building block for the processes in the chemical industry. Next slide, please. Then an overview of Porthos. Well, our infrastructure consists of 4 components. You have the onshore pipeline, the compressor station, the offshore pipeline, and the platform. The only thing that already exists is the platform. It's still in use. And unfortunately, there's no old gas line between the platform and the port that we can use. The gas line that exists goes north way and not to the south. And as you see, the onshore pipeline is approximately 30 kilometers long, and well, passes next to all the industry available there in the port area, which make it extremely handy for our open access network. Next slide, please. The project Porthos is led by 3 state-owned companies: the Port of Rotterdam, EBN, and GasUnie. And for the first stage, we have 4 potential customers: Air Products, ExxonMobil, and Shell. And the capacity of the field is 37 megatons, which we intend to store 2.5 megatons per year. And the 2.5 megatons per year is based on the SD++ subsidy, as mentioned earlier by Tom. And because of the subsidy lasts for 15 years per project, well, it's an easy calculation of 37 megatons divided by 15, which gives us 2.5 megatons per year. The system that we built is a bit larger than that. So, the construction cost is around the 450–500 million euros. Next slide, please. This slide gives you an overview of all the parties concerned for this project. You have the state-owned companies, the private companies, or clients, and the government, naturally. And this also gives you an overview of all the chicken and eggs problems that we've encountered the past few years and that we have solved or are still solving. And I think that the explanatory, or to give you an example, as state-owned companies, we want to build the infrastructure, but to build it, we first needed clients. The clients, they needed the infrastructure, but they needed the funding, because they still had a gap for the transport and storage costs. And the public authorities, before making the funding available, wanted to be sure of getting the infrastructure. Well, eventually the solution for this was from our side with the clients a joint development agreement, in which we both said that we were going to build and they were going to build and research their capture installations, and the SD++ by public authorities that made the funding available to achieve this. Next slide, please. Then, well, there are still a lot of challenges to solve the coming months and years. I just wanted to highlight one, and I think that's the stakeholders and communication. Tom also mentioned that CCS is still a bit of a controversial subject. And the past few weeks we had some media attention with some newspapers highlighting the SDE++ subsidy scheme opening up for the first time for CCS, with some articles mentioning taxpayers paying for the waste of the industry to achieve this. At the same time, we also see a growing support, as in more and more politicians and NGOs who are more and more convinced of the necessity of CCS to achieve the climate goals. Next slide, please. And for the coming years, we're working towards a final investment decision at the end of 2021, 2022, depending on the permits. And this will not be a simple FID because 7 parties have to take their final investment decision, or 3 mother organizations, as in Port of Rotterdam, EBN and GasUnie, and at the same time, or 4 customers will need to take FID at the same time. So still a lot of work to do, but we're all convinced that the construction of the system and being operational is still a matter of time. Well, thank you for your attention, and I'll be glad to respond to some of your questions.
Thank you all for the opportunity to talk to you about carbon collectors. Yeah, and today I'm looking forward to tell you more about our flexible CO2 transportation and storage service. I'll start with the first slide. So why do we need this? It's quite simple. It's because CO2 emissions are unavoidable today and will be unavoidable for quite some time to come in some industries, the so-called hard-to-abate industries. We all know them. It's the steel industry, it's the cement industry, chemical plants, waste-to-energy plants, generally speaking, high-temperature processes. Go to the next slide. And these industries create important products, which we will need for quite some time to come. I'm sure we all agree on that. But the associated emissions are creating a growing environmental, economic, and the license to operate problem. Next slide, please. And that's why we need action now. So we think it's really key that there's concrete action in the short term, and CCS is a key solution to achieve that goal. Generally speaking, CCS is that, but I think a combination of CCS solutions together need to offer the flexibility and scalability needed to actually have the large impact in the short term that we want to achieve. So flexibility in terms of the locations of the emitters and the locations of the storage locations, which need to be connected, but also in terms of the volumes. Volumes from different emitters vary. They even vary in time and in duration. So flexibility and scalability with all the different CCS solutions is what we need to have. So then if we go to the next slide, the Netherlands, and we've heard this number earlier today as well. The Netherlands have committed to reducing industrial CO2 emissions by another 14 million tons per year by 2030. And if you go to the next slide, Carbon Collectors is focused on the industrial clients, and we want to unburden these industrial clients. There's a good Dutch word for this. It's called Onsorhen. But we want to unburden our clients through a flexible, cost-competitive CO2 collection, transportation and storage service, which starts at the end of their capture plant. Next slide, please, because now I'll explain a little bit more on what this would look like. So in its simplest form, we need to find a way to connect the different CO2 emitters to the different storage locations. And you've seen it on Tom's map. There are quite a few different gas fields in the North Sea that are either almost ready for becoming a CO2 storage location because their gas production is running out, or in some years to come, we'll get to that stage. Next slide, please. And what we offer the emitters is to actually unburden them by taking the CO2 from their plant and making sure that it's safely stored in these offshore storage locations. So the emitter needs to build a capture plant, or in some cases, the CO2 is already coming out of their current production process. And we make sure it gets to the offshore storage locations. And maybe I'm repeating a little bit some things that Tom has mentioned as well. The offshore storage locations in gas fields have many advantages. First of all, they've got huge storage capacity, but also importantly, they've got a proven track record. Yeah? Gas has been stored in those fields for millions of years. On top of that, much of the infrastructure required to turn them into storage locations is already there. Yeah, so these gas fields have wells in them, and they have platforms that we can use to access the subsurface storage. If we go to the next slide, because of course it's not as simple as that one. There are a few steps that need to take place, and this is what we do. So in 5 steps, the CO2 emitter needs to capture their CO2. We then come in and place a compressor and conditioning unit at the customer's site. And the purpose of that is to make sure that we bring the CO2 to the conditions required for transportation, but also for storage at the end of the line. So our transport conditions are 40 bar and 5 degrees Celsius. And what happens is the CO2 flows at the rate that it comes out of the capture plant via our compressor into an empty barge, a CO2 barge, with pressure vessels, which is moored at the site of the customer. So essentially, that's our storage. Our storage is not an intermediate storage on the quay side. It's in the water, in the barge. And the time to fill a barge, it can be anywhere from hours to days, depending on the rate at which the CO2 comes out of the capture plant. When a barge is full, it's replaced by an empty one. So the process is actually continuous at the customer's site. At the customer's site, it's just like filling a pipeline. We just take the full barge, replace it with an empty one, and the full barge is connected to a pusher tug and brought offshore, as you see in the middle of the third box. And offshore, it reaches the storage location. You see a platform at the end, and we moor the pusher tug barge combination at an offshore interface, and there's many names for it. We call it the TLU, tower loading unit. So the tower loading unit makes sure that the CO2 barge stays put during the offloading process and connects the CO2 from the barge via flexible hose to the injection pump. There's an injection pump located on the tower loading unit. It's powered by the barge, so we bring our own power. There's no additional large power supply required offshore. And then the injection pump brings the CO2 to the right pressure so it can be injected into the wells. And the transfer from the injection pump happens via a very short subsea pipeline. So it's a direct connection to the wellheads. And that's where the offshore operator takes over. So we work with several operators to develop these storage locations, and we make sure that the CO2 is delivered to the wellheads, and the operator makes sure it's safely stored. Now, this is the standard system that works for all sources that are near a port. And we developed this solution together with our partner companies. So you see the names in the bottom of the boxes. It's Petrogas Gas Systems. That's a gas systems integrator, which is involved for us in the whole process from compression to the actual injection of the CO2. It's Wagenborg and Wagenborg Offshore, a shipping company with lots of experience in the Dutch offshore and beyond. And Eastern Sander, the ship builder that's designing and will be building the pusher tugs and the barges, both northern Dutch companies. And then we have Imotco, which is a product line of SBM Offshore, which is world leader in offshore mooring systems. Bureau Veritas has been with us since the beginning, since the feasibility stage, and will provide the approval in principle for both the shipping solution and the offshore mooring solution. Now we can take this a step further, and if we go to the next slide, by taking one extra step. And for that one extra step, we have another partner company called Peterson, which is a specialist in inland logistics over the inland waterways. So what we do for inland customers is actually the same thing, but we've got smaller, lighter ships that will shuttle between the inland source and the transfer point in a nearby port. In the port, actually, we have a ship-to-ship transfer of the CO2 from the lighter inland ship to the offshore barge, or alternatively to a pipeline, whatever makes most sense. Now, if we go to the next slide, we are aiming to get this achieved in the short term. I said it earlier, and it's important, and this is what we've built a system around. So the entire system that we're using here, it has been based on existing technologies. We have a highly experienced team, people with experience in the offshore, oil and gas, shipping, marine environmental engineering, and we make use of technologies that are available today. And together with the strong partners, which you also saw in the previous slide, we've put together a service that can be delivered in the very short term. Go to the next slide, please. So our ambition for carbon collectors is to be transporting and storing 6 million tons of CO2 per year by 2030. Now, if you translate that to the $14 million 14 million ton per year CO2 reduction target for Dutch industry, that's about 40%. Let's go to the next slide, because we actually are looking beyond the Netherlands as well. So since our storage solution is based on the southern North Sea environment, which is very similar to the Irish Sea environment, essentially the service is available to CO2 emitters in the whole area around the North Sea, so all the neighboring countries of the Netherlands. And I think that's an important point to mention. And also clearly, and I haven't said the year, we have this service available from 2023. So as far as we're concerned, we can start shipping the first CO2 in 2023. Next slide, please, because there's an important next slide, which is the role of government. Yeah, so clearly government has an important role to play, and that's why we're all here, and we're very glad to be part of this discussion. And maybe also important to highlight that government has already done a lot to get us this far. So the Dutch government has supported us in the feasibility stages of developing our solution. Importantly, not just our government, but several governments have achieved enormous progress in the London Protocol hurdle, which existed in the past for cross-border transportation and storage of CO2. So that's fantastic. And more recently, we're hearing very positive noises about the ETS directive, which is receiving a new interpretation, which would allow shipping. And of course, that's for our solution, it's key. Now, we're here where we are now, and we still will need continued government support, and not just us. I think all CCS solutions will need continued government support to pave the way for rolling out these CCS projects in the short term. And if we manage to do that, I think we've got a fighting chance of meeting the promises we made under the Paris Agreement. That's my story today. And back to Kevin.
Great. Thank you, Ludo, and thank you to all of the panelists for those outstanding presentations. As we shift to the Q&A, I'd like to remind our attendees to please submit questions using the question pane at any time. I'll ask all panelists now to please re-enable your webcams, and I'll be once again turning it back to Jared to lead this portion of the event. Take it away.
Great. Well, thank you, Kevin, and thank you to all our panelists and speakers. Clearly, a lot of activity and forward progress on CCUS, as we just heard, going on in the Netherlands at the current moment. Perhaps we could start off our Q&A, and we've got a lot of questions that have come in from the audience. I'm trying to group them so we can answer a couple of questions that are similar at a time. But to start us off, just in a general sense, given this forward progress and this momentum that we just heard, what in your own minds do you think has contributed to that? Perhaps all of our panelists could give us just their quick thoughts in terms of, why are we seeing this good amount of forward progress in your country at the current moment? Maybe Tom, we could start with you and then go to Bram and then Ludo. We may have connectivity issues with Tom.
Can you hear me?
Oh, yep, we can hear you now. Please go ahead.
Okay, perfect. I think it's just a general sense of urgency, both on an international level, on a European level, and now on a national level to address CO2 emissions and realizing which is the quickest way to do that. As I pointed out, the step change necessary to emission reductions, it has to start now, and in a way, CCS is a very efficient technology to enable that step change in emissions. To really, if you look at the emission reduction trajectory that's necessary, we need a sharp knick in the line of the trajectory, really, to bring it down really as quick as possible. So I think that's really why now attention is focused on CCS.
Yeah, may I go?
Please.
Yes, well, I fully agree with Tom. And next to urgency, I think also for politics that with the earlier mentioned CEF, that the Ministry of Economic Affairs pointed out, is that some of the industries now, we know they have no alternatives on the short term. So that increases the urgency to apply CCS, because otherwise we don't have another solution for them. And something else you see is that the topic of blue hydrogen also has made CCS, the past year, more sexy as a topic.
Ludo?
I'll add to that. For us, I think there's another dimension, which is really a personal one. We are a group of people who are personally convinced that we really have to do something in the short term to make a significant impact. And we've got different backgrounds, and many of us have had significant careers already in terms of years. And we realize that we, like many others, have been part of the problem that we're trying to solve here, but also that we've got the knowledge and the experience to help solve the problem. And so we're personally driven to really apply ourselves now to realizing the solution that we're proposing.
Great. No, thank you for those answers. Another question that came in, and it ties into what you just mentioned in terms of hydrogen. Just a general question for all of you, perhaps, on how will energy storage and hydrogen, given that those are now much larger part of the conversation, perhaps, how will they impact the future of CCUS in the Netherlands moving forward? Tom, maybe you can start us off again.
No, I think energy storage, large-scale energy storage, is indeed one of the challenges, and I think it also has a link to storing hydrogen as well, possibilities for the storage of hydrogen. Generally speaking, the CCS is looked upon in the Netherlands as a solution for industry, when I think energy storage is currently at least more linked to renewables. There are some clever things to do with power to gas and what have you, but generally speaking, I think the focus in the Netherlands on CCS is very much towards industry, and not so much on the power sector at the moment.
Yeah, I agree with Tom. Otherwise, to add something, in the Netherlands, as a solution for the energy transition, green hydrogen is more often named as the solution. And in case of CCS, now you can see the development of green hydrogen without the development of blue hydrogen, almost, to make the market, to develop the market for the future, the energy of the future. So I think that in that case, even green hydrogen still is a stepping stone for CCS, and blue hydrogen as a stepping stone for green hydrogen.
Yeah, okay, well, I couldn't agree more, of course. Maybe to add to it, indeed, to kickstart hydrogen as a means into the transition, blue hydrogen should make the difference. Green hydrogen is a fantastic goal to achieve, but it will take probably decades before we have enough. So blue hydrogen can really fill that gap, and CCS is obviously then required to do so. And again, there as well, it's important to be able to create the blue hydrogen, or whichever hydrogen, where it's required. So flexibility is key there again, and the more CCS opportunities and possibilities there are for industry, the easier it will be to make that transition.
Yeah, no, thank you for those responses. That seems to dovetail into the broader conversation going on that the IEA and others have been hosting and convening as well, in terms of if you want to jumpstart a hydrogen economy and help decarbonize those hard to abate sectors such as transport or otherwise, that having blue hydrogen at the front end of that to get to those economies of scale, absolutely critical. And it seems like that dovetails into some of what's going on in your country's context as well. Getting to a couple of other questions that have been coming in through the chat. We had one question in terms of how do you ensure the appropriate controls are in place to ensure long-term storage integrity? Perhaps we could get both a government answer and an industry answer in that. Tom, again, do you want to start us off?
Yeah, sure thing. I mean, these are really good questions. Let's just be clear on that. And I think in Europe we have the EU directive on the geological storage of CO2, which has been in place since 2009. And this is a very extensive piece of regulation that covers everything from site preparation, site characterization, the operation phase, monitoring the CO2 in place, and having a number of provisions, both financial and technical, to ensure the long-term safety of CO2 storage. This regulation has been implemented in all member states, including the Netherlands, in 2011, and all CO2 storage projects in the Netherlands will have to be fully compliant with this regulation. So, and we have obviously a strong control with the supervision of this. We have specific teams in place that will provide the necessary permitting and long-term stewardship of these CO2 storage sites. So yes, it's a lot of work, but we know that we can achieve it.
Maybe.
Sorry.
Go. Just yeah, from our side, obviously we have to follow government and the regulations in place. That's clear. And in addition to that, of course, you know, we have experience with these storage locations from essentially the gas producing days and the early CCS projects that some of our people have been involved in. So we apply our knowledge and our experience to design a solution. And I think all of us do this, all the CCS solutions, to design a solution that is, of course, designed to be safe for the long term. And then we'll make sure that it is compliant before anything actually goes underground.
Yeah, and for Porthos, I think the answer lies in the answer that Ludo gave with the knowledge we use from Geiste, who ran the whole gas network in the Netherlands, and EBN, who already was involved in all the storage sites in the Netherlands. And just to add small thing, well, it's also security is also, how do you say, part of the negotiations with the clients about CO2 specs and the standards of metering, and well, that are agreed upon. So that's from Porthos' side.
Yeah, no, thank you for that, and yeah, I think it lots of sides to that conversation, but again, something that clearly takes both government and industry working together to achieve those results. And again, I think most countries, including yours, have a good and a transparent path forward in that regard. A couple of you mentioned the need for inland shipping in some of your opening remarks. Ludo, perhaps a question for you from the audience. When will an inland shipping solution be available? Question number one. And then another question that came in that's sort of related is, you know, are there also pipeline transport envisaged to neighboring countries? Perhaps a hub in the harbor is one of the other questions. So inland shipping and other pipelines, your thoughts on those, please.
So inland shipping, indeed, can be available from 2024. Clearly there, the major hurdle that I see is a regulatory one. So there again, we need support on the regulatory side to make sure that the transportation of CO2 over inland waterways is allowed by the time we're ready to do so. So we have the conversations with the clients who want to do this. We have the solution, so the technical solution will be ready. And of course, in our case, it needs to connect to our offshore solution, which I said would be available from the end of 2023. So 2024, we can have an inland solution operational if the regulatory issues have been solved. And of course, as Tom also mentioned, in terms of the subsidy scheme that the government is working out, also for those inland sources, needs to work. It needs to be suitable for the extra step that needs to be taken to bring the CO2 to the ports. Now, as far as pipelines, I'm probably not the best to answer the pipeline question. Maybe I can bounce that one back to Bram.
Thank you, Ludo. Well, yeah, thank you for the question. Porthos is, for now, the Porthos I presented. So it is the P18 field and the backbone we are building in the port of Rotterdam area. But next to that, we also received from the CEF, from the Connecting Europe facility, a subsidy of 102 million to achieve this project. And with the CEF, we also have obtained not the word obligation, but we got now, how do you say, we need also to work on a more international framework. So that's not part of the Porthos we're working on now, but certainly something that we're looking at for in the future.
Great. No, thank you for those answers. I see we've just got a couple of minutes left, but maybe one general question that we could get a response from all three of you on to end with before we hand it back over to our hosts here. Tom, you mentioned the need for everybody to be transparent about the need for CCUS and to ensure political and public support, I believe is what was on your slide. And Bram, you mentioned the need to have active communication to stakeholders about the absolute necessity of CCUS to achieve our climate goals. Just so the general question to all three of you panelists, what mechanisms do you think are the most efficient and effective to ensure that type of communication? And in a related note, could you see more public acceptance than in previous phases and efforts? Perhaps, Tom, we could start with you in terms of the best mechanisms to ensure that type of communication to the public.
Yeah, it's a good question and a challenging question. I'm not quite sure if I'd describe it as a mechanism, but I think something that's very important and that may have gone wrong in previous attempts on CCS projects is to ensure a consistent messaging between government and industry to ensure that the same messages are coming out and that no conflicting information or what have you are brought across to the relevant to the relevant public, to the public in general, basically. So to ensure that the messaging is consistent and aligned between the project developers and the authorities concerned, I think that's really a key way forward that we need to ensure that. Yes.
Yep, clearly understood. Bram, your thoughts?
Yes, I think that's also an important side for the EU legislation, as in for the ETS and the coming new 10E regulations, and that CO2 infrastructure as such is embedded in those. And one thing I missed from the EU was also a more prominent mentioning of CCS or CCUS in the new Green Deal. And I think that also would help to align the different states to be more positive, or to be able to be more positive about this technique.
And Ludo, from your perspective?
Well, maybe to add a few things, I think it's important that the public understands that CCS is a relatively low-cost, short-term implementable solution. And I don't think we've heard much about that. And I think the picture that Tom showed is a very important one. And it's maybe a bit analytical for some of the public, but the impact that we need to make and the promises we have made is significant, and it simply cannot be done without CCS. And I think part of the message, and it's part of how we talk about it as well, it would be great if we could immediately turn the whole world into a sustainable society using just wind and solar. It simply isn't going to happen. So the reality is we've waited 30 years to get here, and we could have started earlier. We didn't. And now we have this solution, which is a very good solution, can be engineered based on existing experience, existing assets, which also will not be there for 50 years to come. These gas fields have often been around for 30 years or longer, and we can stretch them for maybe another 10 or 20, but that's about it. So it's a relatively short-term solution, and therefore I think we need to take away the fear that this is going to replace the full transition to a completely sustainable world. It won't. It's just a way to make sure that we capture the CO2 emissions in the meantime, and that will make a big impact.
Great. Well, thank you for that. And we've got many other questions that came in terms of our bio-CCS and the impacts of COVID. But I think in the interest of time, I need to thank our panelists for the wonderful Q&A and turn it back to Kevin for some closing logistics to the webinar.
Yes, thank you, Jared, and thank you to all our panelists for that informative Q&A session. And as Jared alluded to, for any questions we didn't have time to get to, we'll try our best to connect with those attendees offline after the webinar. One more reminder about the SEM CCUS Initiative YouTube playlist found by following the link on this slide, or again, searching Clean Energy Solutions Center on YouTube. Our initiative coordinator, I was also pasting the link in the chat if you had a chance to see that. This recording will go up shortly after the conclusion. And if you'd like to learn more about the initiative, please reach out to the coordinator via the various channels provided here, or follow us on Twitter or LinkedIn. at CCUSM or via the LinkedIn URL there. One final time, I'd like to extend a thank you to our panelists and to our attendees for participating in today's webinar. We appreciate your time, and in return, hope there were some valuable insights that you can take back to your organizations. Please enjoy the rest of your day, and we hope to see you again at future events. This concludes our webinar.